So we are going to do today a process called completing the square. Before we start, I want to ask you for your patience, because this is, when I say a process, I mean it is like a process. So it is, but that doesn't mean like, oh, no, it's a good process, but there's like, the first time we do it, you're probably going to be like, whoa, I have no idea what just happened there. We're going to do several together, and hopefully by the end you guys are going to be able to get in tune with the process, and it will go very quickly. Okay? But before we start that, I want to request one thing. So on Thursday, when we did this, I had you all turn your calculators into classic mode because we took all our square roots and put them as negatives, right? Today, you won't really need a calculator. You might want it for just like basic arithmetic, but you won't really need it because instead of writing things as decimals, what we're going to do is just leave them as square root symbols. So for example, in number 15. Divided by 8 first, and you got x squared equals 7. And then you took the square root of both sides, and your answer ended up being plus or minus 2.64. Roughly 2.64, something in there, right? What we're going to do today, instead of making it a decimal, is just leave it as the square root, okay? So we're going to leave it like that. And the reason for that is because it's going to give us less work to do in a problem where we already have several steps. I want to eliminate as many steps as I can. Okay, so we're not going to worry about decimals today. We're just going to leave them in square roots. But I want you guys to recognize that this right here is the same as positive 2.64 or negative 2.64. Just because we're writing it like this doesn't mean it's not a real number. It is a real number. We're just leaving it like this. It's sort of like leaving things as either fractions or decimals. It's up to your preference. My preference today is just to leave it like this. That said, if something is in a radical form, that's what we call that, the radical with the square root. If it's in a radical form, if I have square root of 7 plus 5, are these like terms? No. So I would just leave this like this. And again, that's why I want to leave things in radical form today, because ultimately it will make less work for you. All right? So it doesn't always look the prettiest. I think it looks pretty, but I'm like a mom who always thinks your kids are cute, you know? Like it's these my kids, my numbers are my kids. So I think this is pretty. But if you look at this and you're like, that's ugly, I want to turn it into a decimal, by all means, go ahead. I'm just not going to today. Okay, so you can, I'm just not going to. So that's out of the way. You shouldn't really need calculators, especially for right now. Let's get started on what it means to complete the square. So, we're going to review really quickly. This is called a perfect square trinomial. Does anybody remember why this is called a perfect square trinomial? It's got positives, okay. That's not required though, because this is also has x squared. A perfect square trinomial. It is required though that the c be positive. So okay, so the c is positive. Good. It has an x squared. Gabe, what were you going to say? It has a b and a c, that's true. Is there anything special about the b or the c maybe, Brian?
The c needs to add up to the b.
The c has to add up to the b if you break it down, right? Okay. Let's break this down and maybe that'll help. What binomials would this break to?
3.
X plus
3.
And so what do you notice about those two?
They're
the same. That's when it's a perfect square trinomial. When they break down to the exact same binomial, because this breaks down to 3 and 3, and 3 and 3 add up to whatever's in the middle, our b term. So the only difference down here, they would still be identical, but they would be minus, they can't be 1 and 1, because if it's 1 and 1, then the 9 would be negative. So they have to be the same sign, but in this case, they are what?
Positive.
Negative. So your answers would be positive. Is that what you meant? Like x would actually be 3 and 3. I knew it, you just had to. Okay. Is there a shorter way of writing this? How can I condense this?
Just x squared equals 3.
Squared. Perfect. Okay? So I can condense it just like this. 3 squared. That binomial squared. Because what does it mean to square something?
That is being multiplied by this.
Yeah, shows up twice, right? So this twice can be condensed and written like this. So then this one down here, how can I write this one?
X minus 3 squared.
Squared. Perfect. Okay? Alright, keep that all in mind. We've done this before, this should be vaguely familiar. We are going to use completing the square as a process for solving quadratic equations. So, for the first part, what does it mean to complete the square? So basically, when I say complete something, what is that, in your head, what jumps to mind? When I say complete, finish it, right? So finish, if I said, complete this sentence, the best food in the world is?
Pizza.
That was weird. I was thinking pizza. Alright, so the best food in the world is whatever, insert whatever you want there. But when I say complete, another way we complete often means to fill in the blank, right? So what we're going to talk about here is how to basically fill in the blank of perfect square trinomials. Now, there is a way to do this without having to do a whole bunch of math and a whole bunch of work and figuring out, oh my gosh, what could this be? So let's take a look at this, which I'm telling you is a perfect square trinomial. All right, this is a perfect square trinomial because the A is a perfect square and the C is a perfect square. And there's a relationship between the B and the C. And here's what that relationship is. If I take B and I divide it by 2 and I square that, what's B? 8. What's 8 divided by 2?
4.
What's 4 squared? 16. Okay? So, there is a magical relationship in perfect square trinomials where if you take the B, divide it by 2, and square it, it will give you the C. And why we care about this is because then we can take any trinomial like this and complete the square by figuring out what would go in there. So to do that, here's our B. What's B? 10. What's 10 divided by 2? 5. What's 5 squared? 25. You just completed the square. Okay? So that is completing the square. You're essentially turning any trinomial into a perfect square. Alright? Now, sometimes it's really pretty, sometimes it's not, but the process is always the same. So it's what would complete this square?
81.
9.
You're halfway there, you're right. What did you do to get 9?
You divided it by 2.
Okay, so 18 divided by 2, and then what?
Square it.
Square it to get 81. So to complete that square, that would give you 81. Now it's a perfect square trinomial, and it would factor into what?
X plus
X plus 9, X plus
so
9.
you just plug what you divided.
Yeah, basically like when you divide it, that's what that number should be in there.
It should
Okay.
always be the C. It should always be bigger than the.
Yes, yes. The C should be bigger than the B unless it's a 1, because sometimes 1 times 1 is 1, but 1 plus 1 is 2. That's the only one where it would be smaller. Okay? Do you think it makes a difference? Do you think it makes a difference if this is negative?
No.
No, it does not. How come?
Because it's still dividing it and getting the same
I still divide by 2, which in this case would give me
7.
positive or negative, negative 7. But when I square negative 7, it gives me a
Positive.
positive. So when you square negative, it gives you a positive, so it doesn't matter. And that would give us 49.
Is that
All right?
they were doing plus or something?
Yeah, so that's, yes. So it does not matter because whenever you square something, it becomes positive. All right? The only difference is now in your binomials, what would it be? Now it would be 7, both of them negative. Good. Okay, so that's all this little negative sign tells you.
Would you
That
get
they
wrong
should
if you
look
put
negative.
x plus 7 or x plus 7? Even though it gets the same.
It doesn't give you the same thing because x plus 7 would give you plus 14. and you need it to be negative 14. Okay, the biggest thing to remember is if it's a perfect square, these two things should be
The same.
identical. Yep, identical. Okay, so that's the very basic process of completing the square. What we're going to talk about today is how to use that to actually solve quadratics. Now, when we have a quadratic, this is what I just said. Okay, so all that we just did, b divided by 2 squared, that's what this is. All right, so when you have a quadratic, how many answers are there usually? 2. Why?
Negative and positive.
Not always a negative and a positive. If you graph a quadratic, how many times does it usually touch the x-axis? Twice. Why? Because what shape is it? It's a U. It's a parabola, right? So usually it touches twice. Sometimes it only touches once, and that's if the vertex is on the x-axis. Sometimes what happens? It never touches at all. What's that called? No solution. Perfect. Okay, so typically you're going to have 2 answers, which is why we put that what symbol? The plus minus. That's why in your rewind you needed the plus minus symbol, because whenever you square root something, you get a plus minus. Okay, so we're going to take a left turn and we're going to go down this process called completing the square. So I want you to take a look. We're going to skip these because we just did like 4 of them. This is the long-winded way of writing it. I would honestly not write this. I would just do it in your head. B divided by 2 squared. Okay, so all right, this process right here, ignore those 6 steps. When you're done, if you need to refer back to them, these are the steps that we're going to do, okay? But I want you to ignore them for right now, because we're going to take it a little slower and do it in a little bit differently. Okay, so unlike every other quadratic, we have wanted that to equal 0, right? When we're completing the square, you don't want it to equal 0. You want it to be the A term, the B term, and then where do you want the C? At the end. Okay? So you want the C at the end. So unlike every other thing, you don't want it equal to 0. You want A and B away from C. All right? And the reason for that is because now this is going to let us use completing the square. So bear with me, follow along, and then we're going to do a bunch of these. Okay, so first thing I'm going to do is I'm going to complete the square for my left side. And 15 just stays over there by itself right now. So I'm going to complete the square for my left side. So step 1 is complete the square. Okay, so what would that be? Why?
Because you have to divide 14 by 2.
14 divided by 2 is 7. 7 squared is 49. So Victoria completed the square for us, and that's 49. However, because this is algebra, every time you walk in this door, you know that if I add 49 to this side, what do? I have to add it over here. Okay, so plus 49. Now, this is the step everyone forgets. Don't. Be better than everyone. All right? Don't forget this step. Remember, come in this door, everything has to be balanced. If you do it on one side, you got to do it on the other. Okay, so we completed the square. We now have a perfect square trinomial. So what can we do with it? We can break it down. So the second step is to factor. And because it's a perfect square trinomial, it should be really easy to factor. Because they're going to be 2 identical ones. And what will it look like?
7, x plus 7, x plus 7.
And you knew that it was plus 7 because the 14 was a plus. Over here, what's 15 plus 49? This is where you might want to use your calculator. What? 64. All right, so 64. Now, what's the shortcut way of writing this?
X plus 7 squared equals 64.
And as we learned Thursday, I can get rid of these pesky little 2's by doing what?
A square root.
I can take the square root. Michael says, well, I can just go back up here. There was no 2 there. That's true. But it was there here. It was just imaginary. We want to actually make it go away. So to get rid of a squared, we do the opposite, which in this case is the square root. Not division. It looks like a division sign, but square root. What happens with a 2 and a square root? They do what? Poof, they're gone, right? So what do you have left?
7 x plus
X plus 7.
X plus 7 equals
8.
64.
Oh,
Plus negative 8.
plus or minus 8.
Oh.
All right, plus or minus 8. Okay, so we're almost done because we almost have x by itself. So now what do I need to do to get x by itself?
Subtract 7.
Okay, so this goes away. Now I have x alone. How many answers am I going to have here?
2.
Probably 2. I need to do a little bit of math. What are my actual math problems here? What's the first one?
Positive
8 minus 7 and negative 8 minus 7. What's positive 8 minus 7? 1. What's negative 8 minus 7?
Negative 15.
15. So my answers are 1 or negative 15.
Oh my gosh.
So it's a process. And what I told somebody in the last class is this first one, like some of you might be sitting here, and this is okay. Some of you might be sitting there like, I have no clue what you just did. And that's okay. We're going to do 3 more, and I promise, even if you're not thinking like, oh, I got this by the end, I think you'll at least know where to go a little bit at the beginning. But it is a process. But what I said to the last class is, by the time you get this process, it ends up just being, your hand will be tired because there's a lot of work, but when the process becomes easy, your mind will not be tired. It looks really daunting, but honestly, the hardest part is just your hand getting tired. Okay? So we're going to do a few more together, and then you guys are going to try some. So, end of story, how many answers should you have?
2.
Probably 2. Okay? This one worked out nicely because the square root of 64 is a what? Perfect square. They won't always be. To be honest, I like them better when they're not, because then you don't have to do this. You're just done. And so we'll see one in a minute that looks like that. Okay, so let's do another one together. And again, I would write these down. If you're not writing these down, I would start now. At least get a couple examples copied down. Okay. Now, this looks beautiful because it's in standard form and I love it, except when I'm completing the square, do I want it in standard form? No. I want A and B on the left and C on the right. So how do I get C on the right? Plus 2. So my new equation looks like minus 2x equals 2. Now I'm ready to start. Now I'm ready to start that completing the square process. So the first thing I do is I put in my blank. And remember, it's always going to be plus. Because if it's a perfect square, this has to be positive. And then my 2 is still over here. So who can tell me what fills in that blank? What completes my square?
Plus minus
1.
Just 1. Plus 1. It has to be a plus, so it's 1. Brian, why is it a 1?
Because you divide 2 by
Cut it in half, which is 1, right? And what's 1 squared? 1. Perfect. So it's 1. Am I done?
Ow.
No. What did I forget?
I forgot to add it to the other side.
So I have to, if I add it to this side, add it here. Okay? Now, there's a couple places you can kind of shortcut. This is one of them. You do not have to write this. If you know in your head that 2 plus 1 is 3, by all means, just write that. Okay? All right. So now, what do I do next? My square is complete. Now I factor.
X.
Is it going to be x minus or x plus?
X minus.
Why is it minus?
Because you're
Because
dividing
it's
it.
one, two,
Because of this one? And it's going to be
X1,
1 and
1,
1 equals
3.
3. What's this shortcut?
X minus 1.
Okay, and again, if you can do this part mentally, do. You don't have to write out 2 binomials. You can just write it like this if you know right away that it's going to be x minus 1 for both. All right? So now what do I do? Gotta get rid of that pesky 2, so I square root. What am I left with here?
X minus 1 equals.
Okay. What does it equal?
Plus or minus.
Plus, I know I need a plus or minus.
Square root.
Square root of 3. Why?
Because it would equal this.
Because that will give me a decimal. It's not a perfect square, so leave it alone. All right, could you do it? Yes. Do you have to? No. If it's extra work, just don't do it. Unless you want to because you like decimal. Okay, now last step.
Plus 1.
Plus 1, plus 1, and I end up with x equals plus or minus square root of 3 plus 1. Because, are these like terms? No. So I don't have anything to do there. So honestly, that's why I said I like them when they're not perfect, because I don't have to do any work. I'm done. That's it. Okay? So there's my answer. Is it beautiful?
No.
Yes, I think so. You might not, but I think so. All right? How many answer choices are there here? 2, because there's positive 3 plus 1 and negative square root of 3 plus 1. Okay? So there's both of those answer choices. So it would be a normal parabola. Okay? Now, is this already easier just on the second time?
Yes.
Yes? You don't have to let me if it's not hard. We're going to do one more together. And here's the reason why completing the square is good to know. You don't have this one on the slide. We're going to make this one up together, so you can do this on the back. But the reason completing the square is good to know is because you can't always factor. And sometimes graphing really stinks because it's huge and you don't have a coordinate plane and all that other stuff. So sometimes completing the square is a great option because no matter what the numbers are, you can do them. Now, we're going to make up a quadratic right now. I would write this down if I were you. How do I want it? I want A and B on the left and C on the right. Okay, so A I'm going to leave alone. I'm going to make it x squared. And then I'm going to say, do I want positive or negative?
Positive.
Positive? Positive. Okay. Give me an even number. Any even number? 4.
7.
Okay. And then give me a C. Any C.
4. 8.
8.
Lucky number.
All right. Okay, so here's the one that we're going to complete the square for. How do I start? I need to complete a square. So x squared plus 4x plus blank equals 8. What's my blank? 4. You're at, why is it 4?
Because when you divide 4 over 2,
Guys, I'm hearing a lot of talking and I'm having a hard time hearing if people aren't actually answering. Eyes up here. Okay, I'm sorry, can you go one more time?
So whenever you do it, you put 4 divided by 2, and then you get 2, and then you get the square root of 2, and then you get
2 squared is 4, right? Good. Okay, so 4 divided by 2 is 2, 2 squared is 4. If I add it here, what else do I have to do? To the other side. So don't be everybody. Don't forget that step. So plus 4 on both sides. So now, what does this factor to?
x plus 2.
And
X plus 2.
and then over here, this gives me 12. Good. Could you skip this step and just write this? Yes. I'm not going to because I know there are some people who need to see that written out, so I'm going to write it out. But if you don't want to, you don't have to. You can skip right to here. All right. Now what?
Now
Square root. And we end up with what on the left?
x plus 2.
Okay. And then
Positive, negative, square root.
good. Is that a perfect square?
Yes.
12?
No.
Oh no, wait, 6, never mind.
12 is not. Leave it alone. All right. Plus or minus square root of 12. And then how do I finish?
Subtract 2 on both sides, and then
Are those like terms?
no.
No, so leave it. Plus minus square root of 12 minus 2. And that's it. How many answers are there?
2.
Gabe. Yeah.
Basically, the only time there's like 2 answers to get the
No, this has 2 answers.
oh.
Positive square root of 12 minus 2 and negative square root of 12 minus 2.
Well, I mean, like,
The only time you have 2 different answers is, yes. There are 2 different answers here. I'm just not going to do the work to figure it out. Could you? Yes. If you took this and put it in a calculator, you would get 2 different decimal numbers. But yes, I see what you're saying. The only time you're going to have like x equals this or this is if it's a perfect square. Unless you are the type of person who wants to put it in a decimal form and do that. Which, be that person. Fine. I can figure out whatever the answer is. Okay? All right. I would like you to do number 1 and number 4 on the practice at your boards go.